All right, so today's notes are on rational exponents. Our content objective is to simplify expressions with rational exponents, and our language objective is to use the correct terminology to describe roots, exponents, and fractions. So first thing I want to do is define rational or fractional exponents. And those are, or a rational exponent is a root or a radical sign that is written as a fraction where the root becomes the denominator of a fractional exponent. So again, the index becomes the denominator of a fractional exponent. So you have an exponent that's a fraction, and it is representing a root. So a fractional exponent is actually just a root. The only thing for this to work is that n must be a positive integer. You can't have a negative root. That's not a thing. So before I delve into more details with this, I wanted to see if that definition made sense to people. So if you can try on your own to rewrite these as exponents, that would be helpful. Pause it so you can try it on your own. I'm going to go over it now. So here my invisible index is 2. My base is x. So my denominator is going to be 2. My numerator is 1. So this would be rewritten as x to the 1/2. Here I would have 8 to the 1/3. So again, the index was 3, so the denominator becomes 3. And last but not least, my base, the whole thing is xy, so that whole thing would become xy to the 1/8. So xy in parentheses to the 1/8, because this index here, sorry if you're having trouble seeing it, but that index is 8. All right, so that's going from a root to an exponent. Let's see if it makes sense to go the other way. So if you can, I want you to try to use some of this knowledge to go the other direction and simplify. These are a little bit trickier. They're asking you to go a little bit further. But if you want to try them, that's great. Otherwise, I'm going to go over them now. The first thing I want to do is write this as a root. So this would become the cube root of 216. So again, we have the cube root of 216. 216 is actually 6 cubed. If you did not know that, you could also make your factor tree and find your 3 of a kind. But since I know the cube root of 6 cubed will be 6, my fully simplified answer here will be 6. So for this one, there's actually 2 ways you can do this. So you could use, you can rewrite them as roots. So I'll do those as your first method. So I have root 7 times root 7, which becomes square root of 7 squared, which just becomes 7. So here my answer will be just plain 7. The other way I could do it, if you thought of this, which we're going to talk more about later, is I can use my laws of exponents. So I can add, as I'm multiplying two things with the same base, I can add the exponent. So 1/2 plus 1/2 is 1. So I have 7 to the 1, which is just 7. So either one of those methods would work in that situation. We'll talk more about this one later since it might not be as intuitive. But if you rewrote them as roots, multiplied, simplified, that will still give you the correct answer. The next thing I want to talk about, or the next key point I have for today, is that we can rewrite, not just, so in all these examples, I had 1 as the numerator, but what we can actually do is rewrite roots with exponents as fractions that do not necessarily have 1 in the numerator. So whatever your base is raised to the power of becomes the numerator. So again, the index always stays as the denominator, but the exponent on your root becomes the numerator. And that doesn't matter if the exponent is under or outside of the radical. Either way, it can become the numerator because our laws of exponents say when you're multiplying things, you multiply straight across. So I can show you an example of why this works in class, but ultimately it doesn't matter if your exponent is inside or outside the radical, it'll still be rewritten as the base to the exponent over the index. So again, more quick checks. I want to make sure this is making sense to you so you can see some examples, but try these on your own. I'm going to go over them now. So for this one, my index is going to be 7. My base is x and my exponent is 3. I could also write that on the outside. So I have a base of 7, x, and then 3 on the outside. So it doesn't matter if that exponent is inside or outside, but it needs to be 3 and the index needs to be 7. So y similarly has an index of 3 and the 2 can be inside or outside. So I have the cube root of y squared or the cube root of y squared. Either way, it's inside or outside. It doesn't matter. It can be written as either one. And last but not least, this I have the fifth root of xy, sorry, that's in parentheses, to the fourth, or, sorry, that's hard to read, the fifth root of xy all together in the root to the fourth outside. So if it's inside, it needs to be in parentheses. If it's outside, it doesn't need them because it's implied by the root. But those are the two ways you could write that last one. All right, so again, I want you to try this one on your own if you can. It's going the other way. So this one we went from fractions to roots. Here we're going from roots to fractions. So try that one out. I'm going to go over it. So this one would be equal to a, the numerator would have to be 5, and the denominator, my invisible index is 2, so it would be a to the 5 over 2. So it would become a to the 5 over 2. This one would become b to the 3 would have to be the numerator, and the denominator would have to be 5. So the index is 5, so the denominator would have to be 5, so it's b to the 3/5. All right, so that's good for those examples. I'm going to flip the page because I have a little bit more to talk about. So our next key point is that all the properties or laws of exponents that we learned about earlier this unit apply to these fractional or rational exponents. So we're going to need to add, subtract, and multiply these fractions like we do with our laws of exponents as well. So I'm going to go over an example of that where I need to simplify two roots using these properties. So here I am asked to simplify the fourth root of x cubed over the eighth root of x squared. So if you're having trouble reading that, sorry, these are so small, but that's the eighth root of x squared in the denominator. So my first step is going to be to rewrite these as rational exponents or fractional exponents. That becomes x to the 3 over 4 over x to the 2 over 8. Now I'm going to use my laws of exponents. So I know since I'm dividing two things with the same base, I can subtract their exponents. So I'm going to rewrite this as x to the 3 over 4 minus 2 over 8. So again, because I'm dividing two things with the same base, I can subtract their exponents. Sorry, I'm going to pause for a second and talk about why couldn't I just put these under the same radical and simplify? They did not have the same index. So because these didn't have the same index, I can't use my division properties of roots. So instead I have to use my laws of exponents and fractional exponents to simplify. So sorry, back to the problem. So I need to subtract 3/4 minus 2/8. In order to do that, I'm going to have to use my fraction rule. So just a refresher, in order to subtract or add fractions, so in order to add or subtract fractions, I need a common denominator. So to get a common denominator here, all I need to do is simplify 2/8. 2/8 reduces to 1/4. So I actually just have x to the 3/4 minus 1/4, which becomes x to the 2/4. And then I just need to simplify that fraction again. So x to the 2/4 becomes x to the 1/2. So last but not least, I need to rewrite this as a root, and this would just be the square root of x. So that would be my final answer when I write that out. So again, this is going to be tricky in that you'll have to remember to add and subtract fractions, or how to add and subtract fractions. And we can spend some time practicing that in class. But you do need to remember how to get a common denominator, how to multiply fractions is just straight across, so that's not so bad. But you will need to remember those rules. All right, so try some on your own right here. If you don't mind, I'm going to go over them in just a second. So try them on your own. I'll go over them now. So again, my first step is going to be to rewrite with fractional or rational exponents. So I have 3 to the 1/2 times 3 to the 1/4 in this first problem. So my index here was 2, exponent was 1, the index here was 4, the exponent here was 1. Since I'm multiplying two things with the same base, I need to add their exponents. So I have 3 to the 1/2 plus 1/4. Again, in order to add these, I need a common denominator. So I'm going to rewrite this as 3. All I need to do to get this into fourths is to double it. So again, 1/2 times 2 over 2 becomes 2/4. So I can rewrite this as 3 to the 2/4 plus 1/4. So just as a little fraction reminder, you can get a common denominator by multiplying by a number over itself. So to get a common denominator, you can multiply by a number over itself because it is just equivalent to 1. So this becomes x to the 3/4. And then last but not least, I need to rewrite it as a root. The index would be 4, the base is 3, the exponent is 3. I can simplify that if I want to get rid of that exponent because 3 cubed is 27. So I'd actually just have the 4th root of 27 as my final answer if I didn't want to leave any exponents in there. So that's that first example. I'll go over the second one as well to make sure it's making some sense. So the first thing I'm going to do is rewrite this as rational or fractional exponents. So I have x to the 3 over 2 over x to the 2 over 3. So again, this one had an index of 2, so the denominator is 2, numerator is 3. Here it was the reverse, the exponent is 2, the denominator is 3. Since I'm dividing those two common bases, I'm going to subtract their exponents. So I have 3 over 2 minus 2 over 3. So x to the 3 over 2 minus 2 over 3. To get a common denominator so I can subtract them, I'm going to multiply each one. So I'll show you this off to the side. I'm going to multiply 3 over 2 by 3 over 3. And then I'm going to multiply, and that gives me 9 over 6. So I have x to the 9 over 6. And then for the other one, 2 over 3, I'm going to multiply by 2 over 2. And that's going to give me 4 over 6. So I have 9 over 6 minus 4 over 6 as my fractional exponents now that I've gotten a common denominator. So as you can see how I got those. This is a 9, that's a 4. So I have 9 over 6 minus 4 over 6, which becomes x to the 5 over 6. Then I'm going to rewrite this as a root. So I have the 6th root of x to the 5th. And that will be my final answer for that one. All right, so that's all for now. Make sure you write down any questions, comments, or concerns you have so we can go over them together in class.